Hello everybody, Sir Leon here and welcome back to another mathematics video. In this video, we will be looking at angles of elevation and depression. And at the end of this video, you should be able to use the trigonometric ratios to answer questions regarding angles of elevation and depression. So first of all, let's examine an image to see what we mean when we talk about angles of elevation. So whenever you look straight in front of you, that is called the horizontal line of sight. That is a normal line of sight without tilting your head up or down. Now, if you are in a situation like this man here and he wants to look at the board at the top of the tree, he tilted his head backwards and he looked above his normal line of sight. That level that you tilt backwards to see the board, that is called your line of sight. So you have your horizontal line of sight and you have the line of sight in which you look up. Now the angle formed between your normal line of sight, which is straight in front of you, and the line of sight in which you look up at the board in this case, that angle formed between those two is called the angle of elevation. That is a degree in which you look up to see an object above your normal sight in which you would see if you look straight in front of you. And in the opposite, if you look straight in front of you and then you want to see an object below your normal line of sight. For example, we have the observer and he sees an object on the ground. It's at this point. And that angle formed between your horizontal line of sight and the line of sight in which you tilt your head downwards to see, in this case, an object, that is called the angle of depression. Depression means you're looking down. Angle of elevation means you're looking up. So, in questions that deal with angles of elevation and depression, when you draw your diagram and you take out all of the extra stuff, a right angle triangle is formed. So from this right angle triangle, most times you will have to use either one of the trigonometric ratios or you sometimes even Pythagoras theorem at the end of it all to find for a side or even another angle. So let's look at this first example and see how we can answer this question. So this example says the angle of elevation of the top of the flagpole from a point 20 meters from its base is 32 degrees. Find the height of the flagpole. So we can use this ruler to construct and draw a nice diagram. So first of all, we see we have a flagpole. Let's say we have a flagpole here and it says the angle of elevation of the top of a flagpole from a point 20 meters from its base is 32 degrees. So we see the angle of elevation. So if you look straight in front, that would be the horizontal line of sight. And of course, if you look up, that would be the angle of elevation. In this case, it did not tell us anybody's looking, it just tells us the angle of elevation, meaning what angle you must move from the ground to the top of the pole. So that angle of elevation in this case is 32 degrees. And it also said from a point 20 meters from the base. So here's the base and here would be, this entire length would be 20 meters from the base. So here would be 20 meters. And they ask us now to find the height of the pole. So of course, this is the pole that we started out with. So we want to find the height of here. So we can simply call this h. So we see a beautiful right angle triangle is formed and we want to find for the height of this right angle triangle. Or we know from the previous videos, we want to find the opposite. And of course, here would be the hypotenuse and here would be the adjacent. So we want to find the opposite and we are given the adjacent. So let's put down the ratios. So we know the nice mnemonic to remember the ratios would be SOHCAHTOA, or some old horses can always hear their owners approach. So we are given the adjacent. So we see cos and tan has adjacent and we want to find the opposite. So we see we are dealing with tan. So we can say tan theta is equal to opposite over adjacent. Theta in this case would be 32 is equal to the opposite, which is h, over the adjacent, which is 20. So to solve for the height, we just take over the 20. So this will be 20 multiplied by tan 32 is equal to the height. So the height will be equal to, we of course punch this in our calculator, 20 multiplied by tan 32 would give us 12.497, and if you want to round this off correct to the nearest meter, the height of the pole will be equal to 12 meters. And that would be the final answer for this question. So this is an easy example of the angle of elevation and how it can be used to find for a height. So let's look at another example, of course. So this one says, Julia observes a car on a desert plain from her position on the top of a 30 meters cliff. The angle of depression of the car at that instant is 47 degrees. How far from the base of the cliff is that car? So we see we can draw a cliff. We have Julia on top of this cliff. And let's say here is Julia. She would be very tiny. And it says her angle of depression to a car. So we see this cliff is 30 meters high. So it's 30 meters high, 30 meters cliff. So we see the angle of depression to a car. So let's draw the road. So we see we have a car. The angle of depression of the car at that instant is 47 degrees. So when Julie looks straight in front of her, so let me use the ruler. So Julie looks straight in front of her. And then when she looks down, this angle of elevation is 47 degrees. So they want how far from the base of the cliff is the car. So let's isolate this diagram. Let's take out the noise. So first of all, let's draw a line to represent the 30 meters cliff. And then let's draw, you see we have the line of sight for Julia. And then we have the angle of depression, and then we draw in the right angle. So we see this angle formed here is 47 degrees, and we know this will be a right angle, and we know here is 30 meters. And they want us to find how far from the base of the cliff is the car. So they want us to find this distance here. So let's call this distance here x. They want us to find how far is the car, which is here, from the base of the cliff, which is here. So the thing is, we don't know any angle in this triangle. But what we do know this angle formed here. So that angle formed there, and we can see that this is horizontal line of sight, which is parallel to the ground, because if you look straight in front of you, that is parallel to the ground. So we see these two lines are parallel. So if that line is parallel to that line, and we see a Z angle being formed, if this piece is 47, then we know, of course, here will also be 47 because of the alternate angles, the Z angles. So most times when you deal with angles of depression, you have to take into consideration the alternate angle, the Z angle, and that will be the one that you will use. So that is one thing you should know. Whenever you use angle of depression, you will have to use the Z angle to get the angle in the triangle. Because in this case, we did not have an angle in the triangle. So we work it out. So we label the triangle. So we see this will be the opposite. Here will be the hypotenuse, and of course here will be the adjacent. So once again, we see we are given the opposite and we want to find the adjacent. So let's put down the ratios. Some old horses can always hear their owner's approach. Now in this case, we saw that we use tan because we were given the opposite and we want to find the adjacent. So we say tan theta is equal to opposite over adjacent. So we can say tan theta in this case, which is 47 degrees, is equal to the opposite, which is 30, over the adjacent, which is x, the one that we want to find. So we see we need to find for x. So we can take over x. X will multiply. So we'll have x multiplied by tan 47 is equal to 30. Hence x will be equal to, the tan 47 is multiplied. When we take total divides, we'll have 30 divided by tan 47. Hence x is equal to 30 divided by tan 47, the equal to, we see x is equal to 27.975. And if we want to round this off to the nearest meter, we can say and that will be our answer, rounded to the nearest meter. So with that, this has brought me to the end of this video in which I looked at the angle of elevation and the angle of depression. So we see in both instances, right angle triangles were formed. So in the angle of elevation and depression, you will have to use the right angle triangle and the trig ratios that are designed for those type of triangles, for this type of triangle. So ensure after you finish drawing a diagram, make sure you label it correctly. And sometimes in the question, you will have to take into consideration the height of the portion that you're using. So that is one thing you should remember. So with that, I will leave this one for you to try on your own. This is a very nice question to make sure that you have a good understanding. Until then, I'll see you in the next video. Take care.